Let's now do a similar investigation of the cosine function. I want to start with the radian one this time, just for practice and for fun. The biggest thing you need to remember, cannot stress this enough, in your unit circle, you must know that the cosines are the x-coordinates and the sines are the y-coordinates. The cosines are the x's, the sines are the y's. So with that said, let's take a look. Let's start in the center again at 0. So when I have an angle of 0, that's going to put me right here. This is the point on the unit circle. I'm looking at cosine now, so I care about the x-coordinate, and that cosine is equal to 1. So the cosine graph actually starts up here. Rotate pi over 2 radian. That puts us now right here. Cosine is the x-coordinate, so this takes us down to 0. Now, the curvature is going to be exactly the same as the sine curvature was. Because really, I mean, if you just tilt your head, right, the x's and the y's switch position, it's the same sort of thing. What we have is this. At the beginning, as you rotate around, you're not moving to the left very fast. But the more you go, the faster your leftward movement occurs. So that means you don't go down very much at the start. But the more you go, the quicker your graph should go down. There's our first quadrant of the cosine function. In quadrant 2, from pi over 2 radian to pi radian, well, now my x's are going to eventually get down to a -1. X is the cosine, so it starts off, okay, moving pretty quickly as I rotate at a constant rate, moving pretty quickly to the left. Now still to the left, but not as fast, still to the left, but not as fast. So it's going to be a quick down at the start, and then kind of flattens out as you get to that minimum. Next quarter turn, the cosine, the x value, goes back up to 0, and it's going to follow that same idea, not so quick at the beginning and then quicker as you go. And then for your last quarter turn, you should end up back at 1, quickly at first, and then not as quickly at the end. This is a cycle, a period of the cosine function. Now, as you go in reverse, what you're going to see is I want to go from 1 in a negative direction to 0 to -1 to 0 back to 1 again. The cosine function actually is symmetric. It's the same thing left and right when you split it down the middle, because it's going to follow this pattern back and then back up and then and then something like that. And this then continues indefinitely as you continue to imagine spinning around the unit circle in those two directions. Quick Desmos trip. Let's take a look at the cosine function. There it is. So it's at its maximum height right at 0, and then dips down and up forever in both directions. So in degrees, I mean, it's the same thing in degrees. I'm going to make that one this time. But I want to end now with this. You've seen what a cosine function looks like. You've seen what a sine function looks like. I need you to know they're not the same thing. They have the same shape, but notice how, when you graph them both at the same time, they're shifted over from each other. So it's important for you to know sine is the one that goes through 0, 0. Cosine is the one that goes through 0, 1. If you can keep that straight, then the rest kind of sorts itself out for you. Now I want to end with this, and I'll make a GIF page reference so you can see these animations. These are two of the more helpful animations I've seen to help you understand how the unit circle works, where the sines come from, where the cosines come from. So what you see down here, this is, for the sine function, very clearly just measuring the y-coordinate. So as you go up and down, your sine goes up and down. For cosine, it's a little bit trickier because you've got to take sideways motion and convert it into up and down motion. But they do a pretty effective job here. So farthest to the left, farthest to the right. Shows up on the graph as at the bottom and at the top. And then if you're interested at all in the three-dimensional sort of thing, here you go. What we have on the y direction, that would be like a sine function happening. And down here would be like a cosine function happening. So these would be the same shape, but they are shifted off from one another a little bit.